reject.
Okay. We challenge non-contact resistance.
Non-contact resistance, number 6. From number 6.哦，对对，评分表还没发。不好意思，现在。
没听到。
Problem number 6. Please write it down. The person who will present on behalf of
下面那个。
Honorable jurors and fellow competitors, I'm Sophia from Shenzhen High School. My team is Orion, and now we are going to problem 6, non-contact resistance. So this is a problem statement. The responses of a LRC circuit driven by an AC source can be changed by inserting either a non-magnetic metal rod or a ferromagnetic rod into the inductor coil. How can we obtain the magnetic and electric properties of the inserted rod from the circuit's responses? So this is our main focus. Firstly, we think the main focus is what part of the circuit plays a main role in the phenomenon. And the second problem is how the circuits can be used to be a measurement. So this is our outline of the report, including observation, theory, experimentation, and conclusions. So first we will get into the observation. As you can see the observation video, that we first insert the metal rod into the inductor. And we can get to know that this will change the peak-to-peak value of the AC voltage, as you can see here. And then the voltage change disappeared after pulling out the metal rod. And this is the metal rod we use. So here will change. Okay, let's get into the qualitative explanation. And this is our inductance of the circuit has been changed by the rod. And we define the F as resonance frequency of the circuit. And we define the L as the inductance of the inductor. And we define the C as the capacity of the capacitor. And let's get into a theory. AC is a signal provided. And this is how is simulation. Okay, let's get into the LRC oscillation simulation showcase. And as we know that the current will early for 1 period, and the capacity will delay 1 for period. So this L is this is all of our theory. Okay, the impedance needs to be cancelled in order to reach the peak currents. Okay, we want to redefine the problem statement. Inserted to a non-magnetic rod, metal rod or ferromagnetic rod, and get the magnetic and electric properties of the inserted rod from the circuit. And the resonance is about the response. And the magnetic and electric properties is related to the permeability and the conductivity. So we get the resonance frequency, then calculate inductance to require relative permeability. Finally, we also acquire the conductivity from the calculations. And this is our inductor calculation. calculations. Self-induction is performed on the inductors. When we push the rod into our circuit, that we add the current on rod, and the EMF from the self-induction is EMF plus, and EMF from coil's magnetic. Adding current on rod equals to the EMF from self-induction EMF plus the EMF from coil's magnetic fields. So here is the inductor calculation. We define the L as inductance of coil in Harris, and the N equals to the number of the turns in wound coil, and the mu represents that the permeability of the coil material absolute or not relative, and the mu R relative is the relative permeability dimensionless, and mu L is 1 for air, and the mu 0 is permeability for free space. 8% for area for Korea in square meters equals to pi r square r, and the L equals to the average length of the coil in meters. So we know that the L, well, this L, this L will influence the mu R. But however, in this situation, I only work on ferromagnetic rods. Next is our experimentation. This is our experimental setup, including the signal generator, oscilloscope, various rods, and the RLC components. And this is what we use. Okay, it's about the procedures. Firstly, we set up the inductor needed. Second, we start the record of peak-to-peak voltage on the oscilloscope. Third, adjust the signal frequency on the signal generator. Fourth, we record the voltage value under various frequencies to the spreadsheet. Five, we do the calculation, and the calculation is the method is above mentioned. And it's our experimentation about the conductivity, and our independence variables is about inductor type. Okay, so the non-magnetic metal rod inserted circuit peak-to-peak voltage comparison, and this is different kinds of the inductor, including different iron materials. And this is we use 16. So this is an experimentation. I want to clarify. It's our experimentation for conductivity at the short conduction. Conductivity can be observed from peak-to-peak voltage variation, and the detailed theory needed to be conducted. And the coral didn't produce reactance on the inductor, but still having conductivity. And this is it. When the coral didn't produce reactance, it's because its chemistry shifts, because it is a layer and a layer instead of a 3D shape. Next is the experimentation for relative permeability, and our independence variables is the inductor type. So this is our formula, and this is our chart. It is frequency to the peak-to-peak voltage, and by equation to the resonance frequency, inductance transfers to different resonance frequency of the circuit. This is our experimentation for relative permeability. Inductance comparison between calculation and measured value. And the average deviation is only 0.256 mph. And the rod inserted is 0.681 mph. So I think our experiment is quite good, yes. And next is the experimentation for relative permeability. The derivation of relative permeability from the inductance. Average deviation is here and rod inserted is here. So experimentation for relative permeability. That stress conduction inductance can be derived from resonant frequency, and relative permeability is also able to calculate. Only ferromagnetic rods can change in the inductance value due to its relative permeability. And the deviation is larger on inductors having a rod inserted. And finally, we will get into the conclusion. So firstly, relative permeability variation reasons. The gaps between the metal rod and the coil will cause deviation on impedance, leading to different phasal differences. However, every rod will use the same radius. Next, the resonant voltage variation reason. The voltage deviation between inductors contain ferromagnetic rod and a pure coil is caused by the reactance, which is omega L. And about coil's conductivity discussion, because the copper rod is complex structure and the coil rod is a single layer, so its conductivity is not good. Finally, it's interesting fact that we found the ferromagnetic rod produce a high frequency sound at 1030 Hz, and the reason might be Joul's magnetic friction. Okay, because time reasons will skip. So we will get into the conclusion. Firstly, responses of the circuit, resonance frequency for relative permeability. Another question is non-magnetic metal rod or ferromagnetic metal rod, and we say the change in the impedance and change in inductance. And about the magnetic and electricity, relative permeability and conductivity.
Okay, thank you.
Thank you.
So the opponents, please take the floor and ask quick questions for 2 minutes.
So could you please turn to the demonstration video page?
Okay, here.
So as your demonstration video shows, you inserted the rod with your hands, and do you make sure that the rod is inserted vertically into the coil?
I think it won't influence so much because the radius is extremely near the rod wire's radius, so it is almost the same.
Please turn to.
And also, I want to clarify that it is an demonstration, so we use a bar and to make sure it is vertically inserted.
Yeah.
Okay,
So
next question.
please turn to the conclusion.
Is that?
Okay. This one. So, as you mentioned in the fourth slide, non-magnetic metal rod or a ferromagnetic rod change impedance and charge inductance. So, do you mean that they change these two parameters in the same way, or there's some difference?
Maybe I think there will be some differences that we can target that.
So, and that's all.
foundation 是一样的。
So, honorable judges and distinguished contestants, I'm Alan from ND Fresh, and I'm here to oppose the problem number 6, non-contact resistance. So let us begin. So here's a problem statement, and below part is their main focus. What part of the circuit plays the main role in this phenomenon? And second, how this circuit can be used to be a measurement. So here's a summary of their report. So in their theory, they talk about the RLC oscillation and the resonance. And setup, they use signal generator, RLC circuits, and components, and different rods to talk about what the problem wants to investigate. And their parameters is the type of the inductors, and they investigate the changes in frequencies. So, and they really make a good point. So their advantage is that they have good explanation for their experience setup and phenomena. But here's our some suggestions. So we suggest that you could have more considerations of the experiment setup, like more details and more elaborations in your theory parts. And the third one is more analysis for your experiment data. So here's a point that I'm going to discuss with the reporter. First, the changes of eddy currents and how does eddy currents affect the experiment results. And second, how just as I mentioned we'll talk about the non-magnetic metal rod and ferromagnetic rod and how they change the impedance in the experiment. So third, the comparison between the simulation results and the experiment in reality. So fourth, and the assumptions and some other parameters in their experiments. So, and that's all.
Let's go to the next step. The reporter, you would like,
So you please turn to the page that talk about the eddy curves. the eddy current part.
Which page?
Next. 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 This one. So would you please explain that how the eddy currents like exerts on the whole experiment system?
So, like here, you will change the UR.
And
Change the magnetic permeability.
so we need to change the magnetic ability, and what's the relation between the rod you use and the eddy currents that generates in the experiment?
So capacity will change.
So and you explain it like more in details.
And the resonance will relate to what you mentioned.
So
Sorry,
how this-
actually I don't have an accurate idea, so would you explain for me?
Okay. Let us begin with another question. So could you please turn to page 39?
So would you like to speak another okay, here.
So what is the like the relation between the construction of the copper rod and like the
Okay, in reporter's opinion, because in our experiment we found that the copper rod's conductivity is not so well. So we guess it is because it is a layer and a layer. They are not connected between each others. So the conductivity is not so well. And however, this connects with each other in a 3D shape, so the conductivity is better.
so you mean the copper rod has a better conductivity?
Yes.
And could you please turn to the conclusion part?
Sorry. Could I clarify the question you have mentioned?
So what's the and how like how does the non-magnetic metal rod and ferromagnetic rod change the impedance, and what's their differences?
Actually, at that time I answered you that they are different, but I thought after that I thought it was the same. It has the same way to change the inductor value, and it is related to resonance.
And so you mean they're like
I mean there are two similar ways.
so they're different?
No, they're similar.
So they act the same way in the experiment.
Yes, and they both change the inductance.
And so back to the problem statement part. The problem statement is here to investigate how a non-magnetic rod and a ferromagnetic rod, how they act, like how can we obtain their properties from the circuit responses, but just as you mentioned, so they act exactly the same. So how do we know that they are different?
They will both cause the influence, but the value they cause is different.
And which one is the value is? Then what's the difference?
Well, we use different type of inductor. When we use the 600 resistance, and we found out that it depends on the material of the rods.
Yeah. So I mean, what makes them different, like the responses of the circuits?
The resonance is different.
So can you turn to the simulation part? So you do both the simulation experiment and experiment in reality, right?
Yes.
So like what's the relation between there must be some difference between these two ways of experiment. So can you explain what's their difference? So maybe, how do you compare two of them, both of them?
We change the inductor.
What's the difference? Like, the comparison of your simulation case and your experiment case.
So as you can see that